Hi, this is Tim. Today we're going to talk about how to connect an RTD temperature sensor to a CompactLogix PLC. When it comes to RTDs, you have 2-wire sensors, 3-wire sensors, and 4-wire sensors. And probably the most common one you see is the 3-wire sensor, and it's really fascinating how it works. We learned in a previous video that RTD sensors work off of measuring the change in resistance based off the change in temperature. But also you have all this wire connected, which adds more resistance. So in this case, we have 2 red wires. And these red wires go all the way through the cable and they come right here to the end and they actually connect together. So in the end, what these two do is they measure the resistance of all your cabling. And then you can measure between here and one of the red wires, and that's going to give you your temperature, or mainly the resistance of this very end piece. And then finally you have a 4-wire sensor, and all it does is it's going to double up the other wire. And if we go to the CompactLogix 5370 manual, it's really clear what they're doing here. So on page 190, first we see our 2-wire diagram for an RTD sensor. And in this case, it's going to go between VN2 plus and V/IN3 minus for their example here. Now if we scroll down, then we can see here, even right here in the diagram, it's showing that jumper right there. This part is exactly the same. We had 1 wire coming from VN2 plus going through our resistance sensor and then coming back to the V/IN3 minus. But now we have this additional wire going to the VN3 plus. And so that's what it's doing there, is it's measuring that resistance in all your cabling to determine exactly how much of that resistance that it's measuring is the sensor. Now let's make an assumption in this case that your resistance going out is equal to your resistance coming back. Now the 4-wire sensor actually solves that problem by adding another wire to the other side of it. So again, our wiring is exactly the same as the 2-wire. We have 1 wire going to VN2 plus, and then we have another wire coming back to the V/IN3 minus. But now, in addition to the 3-wire sensor's wire that went to the VN3 plus, we also have a wire going to the V/IN2 minus. And so this time, we're going to be able to measure the resistance in this run of wire, and separately, the wire coming back will be able to measure the resistance of it. And then we can take the resistance between those two and get a precise measurement of what the temperature is. So we're going to do it in 3-wire in this case. So in your second set of terminals, about midway down, you're going to see your VN terminals. One thing to be really aware of though, if you notice, the terminal labeling is wider or taller, so you can't look left or right to figure out which one's which. You need to count from either the bottom up or the top down. So I believe that is correct. So let's go into Studio 5000 and we're going to create a new program. And in this case, we're using a 1769 L27 ERM QBFC1B. Also, the L24 above it has this universal input as well that we're using. And we are just going to call this our RTD. And we'll finish. And then on our left side, if we go down into our I/O configuration and into our embedded I/O and then find our embedded analog I/O, we're going to open it up and we want to go to our input configuration tab. Now, in the case of the drawing, since I'm following exactly what it said, it was actually using input 2. So we're going to enable input 2 and then we're going to scroll down, and this is a 100 ohm PT385 RTD sensor. So we select it. Now first notice, when we select that, we can no longer select input number 3. And the reason for that is, if we're using 3-wire, as such as we are, or 4-wire, then we're using more than one analog input. And then for our data format, just to make it easy, let's put it in engineering units. We'll click OK. And let's just download this program. And if you need any help downloading your program or configuring your drivers or anything like that, we have a whole lesson series on Studio 5000 for the ControlLogix and CompactLogix PLC. So look down in the description, I'll have a link to it. And remember to put your controller back in run mode, and let's open up our controller tags. And then remember where we were configuring it. To the left of this embedded analog I/O, it has a 2. And that's where we're at, is we're going to be in local 2. And then since it's an analog input that we're reading, we're going to go into the I. And then there's channel 2 data. Now it defaults to a binary style, and I'm not sure why that is, but if we switch it to decimal, and we can see we got a value of about 197. That has a decimal place of 1 in it. So that is 19.7 degrees Celsius. So first, if you're not sure what that would be in Fahrenheit, we can take 19.7 times 1.8 plus 32. And we get that it's about 67. And yeah, it's right around 67 degrees Fahrenheit in here. Now, if you don't want to deal with that conversion, then you can change that in the module properties. So if we go back to module properties, right there we have units, and we can change that to Fahrenheit. And I'll hit apply. And now if I go to my controller tags, it's showing 672 or 67.2 Fahrenheit. So if I put my hand around it, it should go up to 90 something. All right, and yeah, it's climbing pretty fast. Hold on a second. Let's see if we can do something a little easier here. Now we get a heat gun and we put on it. And yeah, we can see it moving up really fast. And yeah, we're up to 150, 180, moving on up. So there's how you can set up an RTD sensor on a CompactLogix universal input. And in future videos, we're going to talk about how you can either do heating or cooling applications based off an RTD. So I hope this video has been helpful. Don't forget to hit that like button. Till next time. Hi, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!